Okay, 6.5, solving by factoring. So, up until now, this chapter has been entirely expressions, right? It's been quadratic expressions. We've been reducing them down into their factored forms, the forms that look like, 2 parentheses, 2x plus 5 and 6x plus 9, whatever it is, right? That is all fine and dandy, but it's not very useful until you start looking at equations. So what we're going to do today is we're going to step away from the expressions and we're going to look at equations, and we're actually going to solve for x. So our answers are going to be x equals 5 and x equals 2, x equals 9 and x equals 6, stuff like that, okay? Yes, there will be 2 answers, and that's where we're going to start. We're going to start with the fact that there will be 2 answers, and it comes out of this thing called the zero product property. Very, very important property. Very important property. Zero product property. And once again, the name tells you what it's about. Zero product, okay? What it says is that if you have 2 things, whatever 2 things they are, if they multiply together to equal 0, then either the first thing was 0 or the second thing was 0. And let's look at that with numbers, right? If I have 4 times 0, that's going to equal 0, right? Or in other words, what times 4 would give me 0? The only thing that could possibly be was 0. Same thing goes as if the second thing was 0, right? So, or the first thing was 0. So if I had something times 4 equaling 0, then again, that thing had to be 0. The only way for me to get 0 as an answer is if I multiply by a 0, okay? Now that idea can be extended to a polynomial, right? So it can be extended, it can say, hey, if you had x plus 3 and it equaled 0, well then what would you need to times it by? Well, you could say 0, right? It'd have to be 0, right? As another case, if I knew x plus 3 was equal to 0, well then x would be negative 3, and it wouldn't matter what was in the other one, right? So the first thing had to be 0. In order for this first thing to be 0, then x had to be negative 3. Okay, we'll come back to that second part in a sec, but basically the idea of the zero product property says if you have 2 things, whatever those things are, and they're multiplied together and you get 0, one of them had to be 0. Sorry. Okay, same thing goes for functions. If you have 2 functions and you multiply together, either the first one was 0 or the second one was 0. They're called zeros. So any x's, like this in the second example, that give you a 0, right? X plus 3 equals 0. That first one had to be 0, then x equals 3. Those things are called zeros or roots. So when x is equal to negative 3 is called, I should just say is a 0. No, I'm not saying negative 3 is 0. I'm saying negative 3 is a 0, right? We've seen these before when we were solving for them in Unit 5, right? At the very end, we talked a little bit about zeros and synthetic division. So we've seen these before, but now we know what they are. They're numbers that will make the equation equal 0, okay? And we're going to use that to find the 2 answers when solving a quadratic. So let's try out this zero product property. I have these 2 things being multiplied to equal 0, right? I have an x plus 6 and a 2x minus 3. So since these 2 things are being multiplied, one of them has to be 0, right? One of them has to be 0, and otherwise I'm not going to get a 0. So either it's 0 times 2x minus 3 equals 0, or it's x plus 6 times 0 equals 0, right? So one of these guys had to end up equaling 0. I don't get to choose which one. I actually have to solve for both, because there's 2 cases here. So I'm going to just kind of divide my page down the middle, right? So in this case, where the first thing was 0, well then x plus 6 had to equal 0, right? Because that's what the first thing was. It had to equal 0. Now I can just solve for x. Subtract 6 from both sides. If x equals negative 6, then I get it, then I get a 0 there. I get 2 times negative 6, which would be negative 12, minus 3 would be negative 15, and I'm getting 0 times negative 15 equals 0, which is a true statement. So negative 6 is one of my answers. That's if x plus 6 equaled 0. Now in the other case, if x plus 6 if x plus 6 was being times by 0, well then that would mean that 2x minus 3 is equal to 0. right? So I set the other thing equal to 0, and I can solve for it. Add 3 to both sides. I get 2x equals 3, x equals 3 halves. So in this case, x has to be 3 halves so that this second thing here goes to 0. I can multiply it by the x plus 6 and I get 0. Those are the two ways that I end up getting 0. So my answer, x equals -6 or 3 halves. Those are my two answers. Quadratics have two answers. Two answers. Okay, every single time. Make that a huge box if you're going to forget. Alrighty. Sometimes you'll see it represented like this. This just means x such that, so you can kind of just ignore that part. And notice we get the same thing. Alright. So that's what happens when you have something like this setup. Now this setup, if you notice, if I kind of just ignore this part for a minute, well, this looks like a lot of our factored forms from before in 6.1 through 6.3, right? And 6.4 technically. So what we're going to do the rest of the day is exactly what we've been doing, 6.1 through 6.3, and then we're going to go one step further and set each one equal to 0. Okay, that's the only thing we're adding on. It's everything you already know, and then we're going to add on the equal to 0 part so we can actually find an answer. Okay, and you'll notice, even in this problem, we did not end up with plus or minus 6. Okay, never, rarely, like a 1 in a million chance you may end up with plus or minus 6. You just don't expect it. Okay, if you get 6 as one, I'm sorry, the only way to find the other one is to actually go and solve it. You have to do an extra step, boo-hoo, cry about it. Okay. Excuse me, my throat seems to be going for some reason. So since we've done most of this already, since most of this comes out of 6.1, 6.3, I'm just going to jump right into example 1. Okay, example 1.2. 4x squared plus 5x plus 1 equals 0. What I'm going to do is pretend I don't see that right now. And I'm going to pretend the instructions say factor. Okay, I'm going to come back to that part in a minute, but I'm going to pretend this says factor. Okay, so I have 4x squared plus 5x plus 1. Well, I don't see a GCF, right, because 1. And I don't see any x's across the board. There's no number they have in common, no GCF. Bummer. It's not 4 terms, so I can't use grouping. It's not a special case. They may have squares on both ends, but this middle one isn't 2 times 4 times 1. That would be 8, so it's not a special case. Okay, so I'll just use trinomial factors. Or factoring trinomials, pardon. So a times c would be 4 times 1, which is 4, and b is equal to 1. What two numbers, b is equal to 5. What two numbers are going to add to 4 and multiply to 4 and add to 5? That would be 1 and 4. 1 and 4 will do that. So now I'll take this guy. I'll say 4x squared. Instead of plus 5x, I'll say plus 4x plus 1x. Right? Plus 4x plus 1x. And then I'll keep the plus 1 on the end. Factor by grouping. Here they've got a 4x in common. What's left over is an x plus 1. Here they've got nothing but a 1 in common. What's left over is x plus 1. I get 4x plus 1 times x plus 1 as my factored form. Now if I was doing just factoring, I'd be done here. Right? Now I actually have to go back and pay attention to that. That little equals 0 at the end here. So that was my first step. Now I'm going to take this and I'm going to say, okay, now I know this equals 0. They told me well, I don't want to use the same color, sorry. It equals 0. So up until then, it was exactly the same. You factor by playing the game, okay? From here, we're going to use that zero product property. In order for this to be true, one of these has to equal 0. I don't get to choose, so I'll go find both. So if the first thing times the second thing equaled 0, well then the first thing could equal 0, or the second thing could equal 0, right? And I've got two cases. Okay, let's solve the first one. Subtract 1 from both sides. You get 4x equals -1. Divide by 4. X equals -1/4. Okay, so that's the first case. That's the first answer that would give me equals 0. The other side, a little bit easier. Subtract 1 from both sides. X equals -1. That's my other answer. So either one of these answers would make this equation true. and I have solved. Okay, you can write them together. X equals -1/4, comma -1. That's totally fine. You can put them in curly brackets if you wanted, be all fanciful. As long as you show me both answers, though, I don't really care what form you presented it. That's fine. Notice the only additional stuff was pink. Okay, that's the only additional thing. So if you can't factor, if the last quiz did not go over well for you, this is going to be a hard section because you need to know how to factor. So guess what? Go back and learn it. Okay, you're going to need to do that. Alrighty. We're going to jump just a little bit down. We're going to do these in a little bit different of an order. We're going to go to C now, because I want you to show it just plain basic one more time. Alright, so let's try this. So again, I'm going to look at this thing. It's now an equation, right? I know it's an equation. I don't get to do this if it's not an equation. If they're just asking me to factor, I only factor. But since it's an equation, I can actually solve this. I'm going to start, though, by factoring this left-hand side. Let's factor that. So no GCF. Not a trinomial squares. It's not a grouping because it's not 4 terms. Okay, so I'll just do a times c is equal to -10, and b is equal to -3. What two numbers multiply to -10 and add to -3? That would be -5 and +2. All right, I'll plug those in. M squared minus 5m minus 2m minus 10. Factor by grouping. Here, these guys have an m in common. I'm left with m minus 5. Oops, I'm sorry, plus 2m, right? Because that was a +2. That should have been plus. Take out, whoops, a +2. I'm left with m minus 5. And now I have m plus 2 times m minus 5, right? Fabulous. So that should have been review, right? Should have been review. That's how I factored. Now I can remember, if I wanted to keep remembering, I could definitely add =0 this entire time. That's not illegal in any way. But now I can remember that that's equal to 0. Now it's important, right? Because now I apply the zero product property. Now I apply the zero product property. So for this to be a true statement, one of these has to equal 0. So either m plus 2 is equal to 0, or m plus 5. I'm sorry, m minus 5. M minus 5 is equal to 0. I hate when I get over here. Okay, you know what? Let's just do this. So either m plus 2 is equal to 0, or down here, m minus 5 is equal to 0. If m plus 2 is equal to 0, then m has to be -2. And if m minus 5 is equal to 0, m has to equal 5. Those are my two answers. So either m is -2, or m is 5. Cool. Alright, so I'm hoping this is starting to make sense since there's only a little bit more, right? There's only a little bit more. Sometimes you may see tricky things like this. They're trying to be tricky. They're really not that tricky, right? In order for the zero product property to work, 0 has to be on one side. It can be on either side, but it has to be on one side. That is not happening in this case, so I'll make a tiny little adjustment and make it happen. Subtract 2 from both sides. Now I've got 2x squared plus 3x minus 2 is equal to 0. Okay? So don't think that when you see stuff like that, that they're super scary and trying to trick you. You're smarter than that. You are all smarter than that. Don't fall for those tricks, okay? Just move it over. You can have 0 on side. You want a 0 on one side, right? So the first thing to do is get a 0 on one side. Then we can solve from there. So I have, let's see, I'm going to treat this like there was no equal 0, right? I'm going to factor it. I have a times c is equal to -4. B is equal to 3. I have to watch out because it was a positive on the right-hand side, but when I moved it over, it became a -2. So I get a -4, right? Be careful about that. Two things that will multiply to -4 and add to +3. That would be 4 and -1. Now I can go over here. 2x squared. Instead of +3, it's now going to be +4 minus 1. Minus 2 equals 0. And again, I'm just ignoring, I'm leaving the equal 0 part, but I'm not doing anything with it. Okay, I'm not doing anything with it yet. Now we'll factor, oops, equals 0. I have a 2x in common here. I'm left with an x plus 2. I have a -1 in common here. I'm left with an x plus 2 is equal to 0, right? When I take the negative out, I have to take it out of both. And I get 2x minus 1 times 2x plus 2 is equal to 0. Okay, that's the factoring part. Now I will apply the zero product property. If that is the case, right, if this is true statement, then either 2x minus 1 is equal to 0, or x plus 2 had to be equal to 0. Now I got to do both cases. I don't get to choose which one. Alright, so add 1 to both sides. You get 2x is equal to 1, or x is equal to 1/2. Yeah, you're going to end up with fractions sometimes. We saw that in the first example. That's okay. And then over here, subtract 2, you get x is equal to negative 2. So we have 1/2 and negative 2 as our two answers. And we're done, right? So it's just one additional step. Don't think it's a horrible, horrible amount of other extra stuff. All right, let's do another one. Let's keep going. Let's use a different color. Let's use darker. Alrighty, I've got x squared minus 18 plus 80 is equal to 0. So I will factor x squared minus 18x plus 80. Okay, that's the only part I'm looking at right now, solving by factoring. Okay, alrighty. See, a times c, well, a is equal to 1, b is equal to negative 18, c is equal to 80. A times c is equal to 80. B is equal to negative 18. Sorry, good. It's equal to negative 18. Alrighty, two things that multiply to 80, add to negative 18. Ooh, double whammy here because it's negative. So negative 8 and negative 10 will do that. Right? Again, if that's a trouble for you, then you've got to practice. Write them all out. What are the factors of 80? 1 and 80. Negative 1, negative 80. 2 and 40. Negative 2, negative 40. And keep going until you find them. Okay, keep going until you find those numbers. As more of these you do, the easier it gets to find them. Excuse me. Okay, so now we will factor that bad boy. Put it over here. X squared minus 8x minus 10x instead of minus 18x, right? Because that would be 18 together. Plus 80. Factor by grouping. We get x minus 8 and x plus 10. Factor out an x, factor out a negative 10. Sorry, x minus 10. Factor out negative 10, and you get x plus 8, x minus 8, x minus 10. That still equals 0. Now I will apply zero product property. So either this one equals 0, in that case x is equal to 8, or x minus 10 is equal to 0. So in that case, x is equal to 10. And I got my two answers. Now something I see happen quite a lot is people automatically assume their magic numbers will be their answer. Okay? Just don't. Okay? Go through the whole thing. Solve for the two things and then solve. Okay? Because this is negative 8 is not the answer. 8 is. So just keep going. Use your steps. Don't try to use the tricks until you're really, really comfortable using your steps. If you think you've got a trick because I'm lazy and I just want to use the trick, you will fail every time. Okay? Just don't do that. Just go through all the steps. Factor, group, zero product property. Okay? Alrighty. That being said, let's take a look at this one. This one's a little strange, right? It doesn't have a C term. It doesn't have a C term. That's a little weird. So how can I fix that? Well, I could definitely put a C term in. But remember, factoring does not only mean factoring trinomials. Factoring means anything, okay? So when we start with factoring, when we are asked to factor, that doesn't mean we have to go this route. Let's start with what we should have started with. GCF. Always start with GCF. If you could have put a 0 there, you would have been fine, but it would take you like twice the amount of time. So let's work smart, not hard. So 4z squared minus 20z has a GCF of 4z. And when I take that out, I get z minus 5 equals 0. And I'm done. That is my final factored form. Remember, final factored form means you can't take anything else out of either one. That's my final factored form. I can even put parentheses around here if I wanted to. Now I will apply zero product property. In order for this to be true, 4z is equal to 0, or z minus 5 is equal to 0. The second one, you got z is equal to 5. This first one may cause you to hesitate, but remember it's okay to divide 0 by stuff. It's just not okay to divide by 0. So if we divide by 4, 0 divided by 4, z is equal to 0. And we have our two answers. Z is 0 or z is 5. Notice I've never once end up with plus or minus 6, right? Never once. Just don't even try. It's not going to happen that way. You have to do both. But notice if you remember GCF, that problem took about 10 seconds. Alright, let's keep going. We've got about 2 more and then we'll hit the word problems. So, here, again, let's start with GCF. GCF, let's follow our list, the one we talked about in 6.4. GCF, grouping, look for special cases, and then factoring general trinomials. But remember, these two are sort of interchangeable. Okay. Alright, so let's start with GCF, though. I definitely have a GCF here. 3 is common to both of these guys. So I can take it out. M squared minus, I believe, 36. Yep. Is equal to 0. Now I can say, well, let's take a look. Now let's keep going. Factoring on this side. I could stick a 0 in there, but I've got square minus square. This is a difference of squares. So I have 3 times m plus 6, m minus 6, right? Remember those difference of squares? It's a special case. Yay! I love special cases. Alright, and prime, 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 that's our factored form. Okay, good. Now let's take a look at it with zero product property. Well, it says if these 3 things multiplied together equal 0, one of them must be 0. So let's take a look at the 3 cases. There's 3 equals 0. Okay, hold up. Is that ever actually true? Is that ever going to be the case? Not really. 3 does not equal 0, right? So essentially this first case is kind of like, it's garbage. We don't really talk about it. If you want to get rid of it, you can consider dividing 3 to both sides, right? Because you can divide by numbers, so you'd end up with m plus 6 and m minus 6 is equal to 0. Okay, so the first case didn't really make sense, but that's okay. Remember, what are we searching for in the end? We're searching for what m is going to equal, right? We searched for x's and z's, and now we're looking for m's. If there's no m in the first part, there's no reason to worry about it. So just divide it out, right? It's just a common factor. It's just a multiple. It does nothing special. So let's do it for this one instead. I've got m plus 6 is equal to 0, or m minus 6 is equal to 0. So to subtract, I get m is equal to negative 6, or m is equal to positive 6. Yes, I know what I've been saying this entire day just happened to finally work out. But you saw that it was a coincidence, right? You saw it, well, really, it came from the fact that it was a special case. But until you really understand that, just keep solving both sides, okay? Always, always, always solve both sides. I said 1 in a million. There's your 1 in a million. But notice, throughout the day, none of these answers have been plus or minus, okay? It's not a guarantee. If it is, great. Maybe double check your work just in case. Alrighty, but notice, the point of this problem was special cases and GCF, okay? They saved us a lot of time. We could have used general trinomials, but it's the longest way. It works a lot of the time. It's the most recognized way, but it is not the only way, and it's definitely not the fastest way, okay? Always start with GCF, and then consider your special cases, because those two will save you umpteen amounts of time. That's a lot of time. Okay, last one. We've got negative x cubed plus 2x equals negative 6x. Wow, that's not even close to what we've been looking at lately, right? First up, it's got x's on both sides. It's got stuff on both sides. One of these sides isn't even a 0. Well, we've talked about fixing that. The other problem is it's a cubic, so there's going to be multiple factors, right? Excuse me. But let's try one at a time. Okay, let's deal with one problem at a time. Let's first get this side equal to 0. Negative x cubed plus x squared plus 6x is equal to 0. So I moved the 6x to the other side. That's what I did. Okay. Now we've actually factored stuff like this before using what? That's right, using GCF. So let's factor using GCF. And like I said before, this is one of those things is if you see a negative in front, you also want to take that out. So I'm going to take that out as well. I'm going to take out a negative x from everybody. So I'm left with x squared minus x minus 6 is equal to 0. And we saw that can be helpful. You probably saw a few on your homework. That can be helpful when you're factoring using trinomials, right? Because it's easier to have a positive in front than a negative. Doesn't really affect it, but it's just kind of prettier too. 1 is better than negative 1, right? So we'll pull it out. All right, and notice I'm still not paying attention to the side. I'm just factoring this side. Okay, cool. Now let's factor this one. Well, that one doesn't have a GCF. If it did, we would pull it out. We just did, right? It's not grouping because it's not 4 terms. It's not a special case because 6 is not a square. So now we can finally go back to general trinomials. Let's go back to general trinomials. Keep this negative x there. Let's see. Two things that multiply to negative 1. I'm sorry. They multiply to negative 6 and add to negative 1, right? So a times c is going to be negative 6. B is negative 1. Let's see. 2 and 3 are sounding good here. I think the 3 would have to be negative, and yep, we got negative 2, negative 3. That would do that. So we have, let's do some brackets, x squared minus 3x plus 2x minus 6 equals 0. So that is this middle term undone. Everything else is the same. I've added some brackets. I just changed them for parentheses just because I felt like it. But all I've done is really separate that part. Factor by grouping. Alrighty. Still have all this negative x junk and 0 over here. But again, I'm not doing anything with it. Notice I'm literally just copying and pasting. Inside my brackets, though, I can pull out an x. I get x minus 3. And then over here, I can pull out a positive 2, and I get x minus 3. And then it looks like I have an x plus 2 and an x minus 3. That is equal to 0. And of course, I'm going to drag and drop that x as well. So that's my final factored form, right? Prime, prime, prime. Sweet. And that makes sense because I started off with a cube and I broke it into 3 x's. Last thing I'm going to prize zero product property. Zero product property never said it can only be 2 things. That's just the example they gave you. If any things are multiplied together and they equal 0, one of those things had to be 0. So we technically have 3 cases here. Either x is equal to 0, x plus 2 is equal to 0, or x plus 3 is equal to 0. So either the first one, the second one, or the third one is equal to 0. This one's already solved for us. That's convenient. Subtract 2 to both sides. So x can be negative 2. Or subtract 3 from both. I'm so sorry. This should be minus. Just kidding. Because that says x minus 3, not x plus 3. So we add it to both sides. We get x is equal to 3. So our answers would be 0, negative 2, or 3. Any one of those, when you plug that in there, would end up getting a statement 0 equals 0. Alrighty. So that's the only additional step today. 6.5, you just have to use zero product property again. Okay, that's all you got to do. Okay, one other thing we're going to talk about today is using all this factoring stuff to solve problems. Haven't been able to do that up until now because everything's been an expression, right? Everything has been a jumble of algebraic terms. Now that we actually have an equal sign in there, we can solve for real numbers. So let's go ahead and solve for real stuff. Alright. Okay. A piece of sheet metal is in the shape of a parallelogram. The longer sides of the parallelogram are each 8 meters longer than the distance between them. The area of the piece of sheet metal is 48 meters squared. Find the length of the longer side and the distance between them. Okay, so I'm going to start by translating. That's a huge paragraph, right? There's some things in here that sound important. Parallelogram sounds pretty important, right? The longer sides are each 8 meters longer than the distance between them. That sounds important. Area is 48 meters squared. That sounds important. And find the length of the longer sides and the distance between them. Okay. That's the question, right? Notice I took giant sentences like the area of the piece of sheet metal is 48 meters squared. I only underlined area and 48 meters squared. That's all I cared about. If I even wanted to make a list down here, that might be even more beneficial. So parallelogram. What does that look like? That looks like 2 sets of parallel lines. So one of those slanty triangles, or slanty rectangles, pardon me. The longer side is 8 meters longer than distance between. Okay, so if I was looking at my picture, let's draw a bigger picture here. Alright, so let's draw our parallelogram over here. Okay, so we've got some sides here, right? So it says this side right here, the longer side, is 8 meters wide than the distance, or 8 meters longer than the distance between it, right? The distance. So it's not the other side, it's the distance between them. It's this distance right here. Interesting. The area is equal to 48 meters squared. Okay, looking good. All right, how am I going to use that information to find the longer side and the distance between them? So finding both of these. Maybe we can call this the width, right? Because that's really what it is, the width. This width right here, that would be like a height or something. Maybe we could call it height. I don't know. Whatever you want to call it. Well, let's remember some formulas. Formulas for area of a parallelogram. Since we've got area going on here, that's maybe sparking some ideas here. What's another way I can represent area? Well, area is equal to length times the height, right? It's equal to the length times the height. That's cool. I know a few things about the length and the height. I know that the length is 8 meters longer than the height, right? The length is 8 meters plus the height, right? So the height plus 8 meters is going to be the length. Okay, that's cool. So what if instead of calling it h, I called the height x? Because, why not, right? So let's call this x, right? So h is equal to x, and the length is going to be 8 plus x. So you see how I used h to find L? Right? Now I've got two expressions. So I'll go plug everything I know about area, height, and length into my formula. So 48 was area, length is 8 plus x, 8 plus x times that height, x. I have a formula. Okay, so that was all translate. Using the area, the height, and the length to find a formula containing x. Now I will solve using the stuff we've talked about in math class. Well, this is kind of hard to solve as it is, so why don't we go ahead and kind of get rid of the parentheses on this side. We end up with 48 is equal to, let's see, x squared plus 8x. I just kind of put them in order. Then we'll subtract that to the other side. I'm going to go up here. X squared plus 8x minus 48 is equal to 40. And yeah, I put the 0 on the other side, but big whoop, right? Now it looks a lot like what we've been doing today. Okay, so let's factor it. Two numbers that multiply to negative 48 add to 8. We'll go with 12 and 4. Positive 12 and negative 4. So let's factor that. So I get x squared plus 12x minus 4x minus 48 is equal to 0. Factor, get x plus 12 minus 4, x plus 12 is equal to 0. So you have, x minus 4, x plus 12 is equal to 0. And then, so now we factored it, right? That's our final factored form. Zero product property tells us that we need to go one step farther. If this is equal to 0, then x must be 4. If this is equal to 0, then x must be negative 12. Awesome. And we're not quite done yet, though. We got that we finished solving, which is awesome. But now we got the translate back step. Think for a second. There's two answers here, but which is the only one that actually makes sense? X equals 4. X equals negative 12. Well, what was x? Do you remember that when we started this, that x is equal to the height? The height cannot be a negative 12. That doesn't make any sense, right? So the height must be 4. So our final answer says h is equal to 4, height is equal to 4, length is 8 plus that, right, or 12. And of course we want to smack on meters and meters. And we have our height and our length. multiply them together, and you can see that, yes, the area would be 48. All right, so that's how you'd solve one of these problems, okay? You've got to translate, solve, translate back. It's the same as any other problem. Let's do one more. Quadratic functions are used to describe the height of a falling object or a projected object reaches in a specific time. For example, if a small rocket is launched vertically upwards from ground level with an initial velocity of 128 feet per second, and then the height after t seconds is defined by negative 16 t, h of t is equal to negative 16 t squared plus 128 t if air resistance is neglected. This is a very true physics formula. Negative 16 is the acceleration towards the Earth, so think gravity in meters, not in feet, sorry. And then 128, that was the initial height. So it's not really in feet, sorry, it's supposed to be in meters, but that's okay. After how many seconds will the rocket reach A, a height of 220 feet, or B, the ground again? So let's start with A. Let's kind of divide up the page here. Okay, so this part will be A, right? Let's take a look at this function they gave us. First off, it is quadratic, right? It's got a degree 2. So h of t is equal to negative 16 t squared plus 128t. Now it's very important that we think about what these letters mean here. Because remember, in a problem, those letters actually have meaning. T is t seconds, right? And its height is h, right? So the height is h, the t is in seconds. So what is this question actually asking us to solve for? Is it asking us to solve for h, or is it asking us to solve for t? They want to know how long, how many seconds until it reaches a height of 220. So the height is not the mysterious part. That part is 220. So this entire h of t is now equal to 220. The t part is the part we don't know. We don't know what t, when we plug in, will give us 220, right? We don't know that. But we can solve for it. There, we've translated. So now let's solve. Subtract 220 from both sides. We end up getting 0 is equal to negative 16 t squared plus 128t minus 220. Alrighty. Now we could go ahead with general trinomials, in which case we would be trying to find something that multiplies to 3,520 and adds to 128, but that's bonkers. Let's not do that. Let's remember how the first step in factoring. Let's do GCF. So what do they have in common? Well, 128 can be divided by 16, and 220 can be divided, 220 can't be divided by 16. That's a bummer. But maybe, just maybe, 128 can be divided by 4, and yep, 220 can be divided by 4. So let's divide by 4 to everything. So we'll divide by 4 here, divide by 4 here, divide by 4 here. And yes, we have to do it to the other side as well, but it's not going to change anything. It's just going to stay 0. Is equal to negative 4t squared plus 32t minus 55. Okay, those numbers look a lot nicer. They're not horrible, 3,000 numbers. They're still a little big, but we can handle these. We can handle these. All right, so now we need two numbers that multiply to a times c. That's positive 220, and add to 32. Okay, what two numbers multiply to 220, add to 32? Well, it's not going to be 55 and 4. Let's try 6. Nope, 220 doesn't go into 6. Let's try 8. Nope, 220 and 10? 220 and 10. Sorry, 22 and 10. 22 and 10. When you multiply those together, you get 32. When you add those together, you get 32. When you multiply them, you get 220. So those are our two magic numbers. All right, let's go ahead and factor. I'm running out of room, but that's okay. So negative 4t squared plus 22t plus 10t minus 55. And that still equals 0. Factor by grouping. Okay, 4 and 22 have at least a 2 in common, right? And I'm going to make it a negative, because why not? Equals negative 2t. I'm left with 2t minus 11. Over here, these guys have a positive 10 in common. I'm sorry. They don't have a positive 10 in common. They have a positive 5 in common. And I get 2t minus 11. So it looks like 0 is equal to negative 2t minus 11. No. Plus 5. Sorry. Negative 2t plus 5 and positive 2t minus 11, right? So those are our two factors. Alrighty. I'm actually going to zip up here. We'll start B in a sec. I've run out of room. That's okay. B's not going to take as long. So if this is truly the case, right, we factored this down, 2 and 5 have nothing in common, 2 and 11 have nothing in common, so it's prime factorization, right? We've got down to our final factored form. If that is truly the case, then one of these had to have been 0. We will apply zero product property. So either the first one was 0 or the second one was 0. Alright, let's solve both of these. Not 0. Subtract 5 to both sides is equal to negative 2t. Or we get positive 5 over 2 is equal to t, right? When I divide a negative by a negative, it becomes a positive, so I get 5 halves is equal to t. Or subtract 11 is equal to 2t. Divide by 2, you get 11 over 2 is equal to t. Or in other words, if you're more of a decimal kind of guy, 2.5 or 5.5. Alrighty. Which one of these makes, so we solved, right? We solved it. Which one of these actually makes sense? That's that translate back part. Which one of these makes sense? It's hard, right? Because they're both supposed to be seconds. They actually both make sense. What's happening is you've got this, what is it, rocket? Small rocket, yeah. You've got this rocket, and think about what happens when you shoot off a rocket, right? It goes up, and then it comes back down. And it says, at what point is this height going to be 220? Well, it's going to be 220 right here, and it's going to be 220 right there. Right there and right there. So at 2.5 and at 5.5. So both of these actually make sense. So instead of writing or here, let's write and. And we have our final answer. So that translate back part when it comes to quadratics is very important. It depends on the context. If we were talking about, if it was one of those was negative when we were talking about time, then that one wouldn't make sense. But since both of these are positive, it does make sense. All right. Last thing, let's solve that other one. That second question says, when will the rocket, how many seconds will the rocket reach the ground again? Okay, so this one's a little trickier because they don't just tell us. What is the height when we reach the ground again? That's going to be a 0. So when we reach the ground, it'll be a 0 height, right? Let's go ahead and solve this one. Oh, good, it's already equal to 0. So I'm going to start by factoring. I don't need to do that minus 20 switch, right? Even better, it's already equal to 0 because now I don't have a constant. I can just use GCF. I can start with GCF. Take out a 16. I have t squared plus 8. Awesome. Okay, final factored form. That's it, right? T squared and 8 have nothing in common. They're not difference of squares because it's not a difference. I could stick a 0t in there, but I'm going to find that it doesn't really help me. So I'm just going to leave it as it is. And instead, I will divide the 16 to both sides. Oops, those go away. I get 0 is equal to t squared plus 8. Subtract 8 from both sides. And then I can get rid of this exponent by taking the square root. I get the square root of negative 8 is equal to t. Sorry, that should have been a negative. Just kidding, my apologies. Hold up, I dropped a negative. Let's try that again. See what happens when you drop a negative? You get things that don't make sense. So, just kidding. The equation is 0 is equal to negative 16t squared plus 128t. Okay, now I'll try GCF, and I can divide by negative 16 to everything. I can pull the negative 16. I'm sorry. I can pull the negative 16 out. So I have 0 is equal to negative 16 times t squared minus 8. Right? That sounds a little better. Minus 8. And we end up getting 0 is equal to t squared minus 8 when we divide 16 to both sides. So 8 is equal to t squared. Take the square root. Square root of 8 is about 2.82 seconds. And so our final answer is 2.82 seconds until it reaches the ground again. And we're done. Alrighty. So that's how you would use it to solve a rocket problem. Okay, so rocket, it's again, just translate it, figure out which one you're going for. Sometimes they just ask you to plug in for t. We saw that in a couple chapters ago, right? They just want you to evaluate. And sometimes they do want you to actually use factoring to solve. Okay, so you have to figure out which one which. That's the translate part. Solve using factoring, and then translate it back. Which one of those would actually make sense? Same goes for area problems as well. Alrighty. That is it for Chapter 6. You may finish your homework or email me if you have any questions. I'll see you next time.